All right, so get your notes out that we started yesterday. I think we finished.
We finished the 4 pi 3.
What? 4 pi and 3? Oh, okay. So, no, I want you to talk to me, people. I don't want y'all to like treat me like a leper and like you can't talk to me.
Can we plug our
YouTube?
Hey, can we plug our social media?
No.
Add me on Snapchat.
Follow me on MySpace.
I'm grounded on all social media.
Okay, so this is the last question. Dang, I can't find it. Here it is. This is the question that y'all did, right?
Yes.
Okay. So, before we go on to show you something that Bella showed me yesterday, all right? So, the unit circle, I know you think, oh, we already had that memory test. People, listen to me. If you are a unit circle person, it's an amazing thing, okay? So, it's very good to be a unit circle person, all right? Does that mean that the unit circle is the only way that you can get the answers?
No.
No. You can also draw the triangles, okay? You also, stop.
Yes, ma'am. Immature.
So, you also can use this chart that we did yesterday, right? What's the hardest part about the chart?
Tangent.
Tangent. Tangent is the hardest part of the chart because kids don't understand that when you do, tangent is sine over cosine. Do y'all agree with that?
Yes.
Sine over cosine. So if I'm going to do the tangent of 0, it's going to be the sine of 0, 0, over the cosine of 0, which is 1. What is 0 over 1?
0.
0. Okay? You didn't want to hear it, Eli. Don't be asking me any
I was
questions.
just gonna ask to take a picture of it later.
Okay. If I'm going to do 30, sine of 30 is 1/2. Cosine of 30, the square root of 3 over 2. When you do fractions, you only look at the numerators, right? So 1 over the square root of 3. Are you with me?
Yes.
45, the sine of 45 and the cosine of 45 are the same thing, people. So that's 1. The sine of 60, the square root of 3 over 2. The cosine of 60, 1 over 2. So the square root of 3 over 1. 90, sine of 90 is 1. Cosine of 90 is 0. 1 over 0 is undefined. All right? So here's what I'm going to say. If you're not good at that, if you just looked at that and when I did it, you went, whoa, wait a minute. Then I would say you need to write these. Does everybody need to write them? No, Tanner was a chart person. He never wrote this down here. But he knew exactly what to do. He would say 0, sine 0 over 1. He knew that they just go backwards. And so he used that. And that was fine for him. Okay? But that's probably the most missed thing is the tangent. Okay? So be careful about the tangent. All right. Anybody got a question? Everybody good? Oh, but I was going to show you what Bella showed me. This is what Bella showed me on the unit circle. It works because of it doesn't work because of the way I teach it, but the way I teach it is I don't know how to say that without sounding conceited, but anyway. Okay, so we're gonna I'm gonna pull these diagonals down. You can take this denominator and this numerator and add them together and get this number right here. 3 and 1 make 4. 4 and 1 make 5. 6 and 1 make 7. They work because you went to 1 and then you added 1 more to them, and the 1 is this denominator. So that's why it works. Okay? Why does it work this way? It works this way because you're going to 2 and you're backing off 1. The backing off 1 is on the top. Do you see how you go to 6 and you back off 1, you're on 5? You go to 4, you back off 1 and you're on 3. Go to 3 and you back off 1. So you're adding these two, you've already backed off 1. And you get this top number. 2 and 3 make 5. 3 and 4 make 7. 5 and 6 make 11. I don't teach it that way because that doesn't teach you any concept about what's going on. Okay? But is it a good check? If you had to draw your unit circle on your test or something, it would be a good check. Just little things like that. Yes?
You could also do it with like the 30s, like 30 times times 5 would be 15, and that's 150, and then 3 times 7 is 21, and would be 210. 3 times 11 is 33, and that's 30.
Yes. And someone else this morning, I don't remember who it was, but their tutor, and y'all, it only works this way because of little things, like 30, and this is 60. 60 is twice 30, right? 90 is 3 times 30. This is a third, this is 2/3, this is 3/3. All right, so there's 30, 60, 90, 120, 150, 180, 210. I'm adding 30 every time in case you ain't caught that. 240, 270, 300, and 330. It goes all the way around like that. Okay, and the 45s that you can go 145, 2 45s, 3 45s, 3 times 45 is 135, 4 45s, and then you can go 5 and 6 and 7 45s. Okay, you can do that way. That's another little check. All right. Another kid said, oh, my tutor taught me this, that if you look at these numbers, the denominators are all 2. If you look at the numbers, they go 3, 2, 1, and 1, 2, 3. Okay? But the 3 and the 2 are underneath the radical. Okay? So just some little checks. All right. Everybody okay? Yes?
Yes.
Okay. So let's do another one of these. Okay, I'm going to do 2 more of these, and then I'm going to do a couple more problems, and then we'll be finished, and I'll let you work on a little worksheet I'm going to give you. Okay, so here's the next one. I want you to find the tangent of negative 210 degrees. Now, first of all, before you do anything, let me make this plain and clear. People, if it does not say use a calculator, you better not use a calculator. Do you understand? If you use a calculator, you're going to miss it. Okay? So, there is no calculator. So, the tangent of negative 210. These are some questions that are going through my mind. Where am I? In other words, I'm thinking about what quadrant I'm in. Don't yell the answer out. You do your own. Okay? The next one, why do I want to know where I am? Because I want to know what's my sign. Positive or negative. Okay? This positive and negative will be the most missed thing on that XYR worksheet that you just turned in. Okay? And the last thing, what's my reference angle? What's my reference angle? So those are some things that are going through my mind. All right, why do I need to know his reference angle? Because the tangent of the reference angle is the same thing as the tangent of this angle, with the exception of where he is and whether he's positive or negative. Okay? So you work that problem. I'm going to give you about a minute. Okay, do you have it?
Yes, ma'am.
Are you getting somewhere with it, or are you stuck?
I'm stuck.
Stuck? Where are you stuck?
At the beginning. Like I know what's
Do you
negative.
know where it is?
Yes.
Okay, so let's start there. Okay, let's start at where it is. I'm trying to find my pen. I lost mine. Okay, so I'm going to go over here, and I'm going to show you. This is the way I do it. Okay, so it's a negative angle, so I'm going to go backwards, right? So here is negative 90. Is it more than negative 90?
Yeah.
Okay, so is it more than negative 180?
Yeah.
Is it as much as 270? So he is somewhere in the what?
Second quadrant.
The second quadrant, okay? So he's in quadrant 2. How far, y'all listen to me, I'm gonna talk about a reference angle before I do the next one, but this is why I'm gonna talk about a reference angle. Because when I say reference angle, my brain goes, how far are you from the x-axis?
30 degrees.
Yeah, y'all, this is 180. How far is that from 180? 30 degrees. That's my reference angle. In the second quadrant, what do you know about the tangent function? Is it positive or negative? Negative. So I know my answer is going to be negative. Remember, all students take calculus. Okay? So in the second quadrant, only sine and his reciprocal cosecant are positive. Everybody else is negative. So I know he's negative. Now I'm going to think of tangent. Tangent is sine over cosine, or y over x, right? At 30 degrees, think about your unit circle. Even if you only know these ones right here, here's your 30 right there. What is the point?
Square root of 3.
Square root of 3 over 2 and 1 over 2. So y over x, 1 over the square root of 3.
What if I did all of them?
Wait,
So you
That's
only
good.
okay.
Okay? All right, does anybody have a question?
So you only need the reference angle to find.
Yes. Now, let me show you this. Let me show you this. If you're a unit circle person, you want me to show you what you did? A unit circle person did this. A unit person circle circle. He said negative 90, negative 180, negative 210. That's that 30. That's really that 150. Do you see what I'm saying? So what's that point right there? That point right there is what? Negative square root of 3 over 2, positive 1/2. Y over x, negative 1 over the square root of 3. And they wrote the answer down.
Wouldn't it be negative square root of 3 over 1, but then, or
1 over the negative square root of 3. Does it matter where I put the negative sign?
no?
Okay, as long as I just put 1, I'm good. I don't care where it is. Just because I put it somewhere doesn't mean it goes with that person. Okay? It means this fraction is a negative. It has a negative value. So I can stick it on the top or the bottom. I'm not looking at who you put it with.
Gotcha.
So, do you understand the importance of a unit circle? You see that right there? Did they think about where am I, what's my sign? No, they just put him right there. All right, are you ready? Now watch this. Reference angles for degrees, you gotta think, how far off that x-axis am I? Okay? What about reference angles for radians?
Oh, super easy.
So what's the reference angle of 3 pi over 4? Pi over 4. What's the reference angle of 17 pi over 6?
Pi over 6.
What's the reference angle of 25 pi over 3?
Pi over 3.
Do you see what I'm saying? Man, is a reference angle in radians, is he sneaky?
No.
People, it's the denominator, okay? That's all it is. It's the denominator and a 1 pi on the top, all right? You can't be sneaky. All right, so let's do this problem. Are you ready?
Yes.
Cosecant of 11 pi over 4. I'll give you a minute. Those are still some things going through my mind, okay? Still some things going through my mind. All right, you ready? Okay, something, just because you know the unit circle, does he help you a lot with this?
No.
People, you still have to have some common knowledge, okay? You still gotta know where this guy is, okay? You still have to know where he is. So, here's what I would do. How many times does 4 go into 11?
32.
2 times, with how many left over?
3.
2 and 3/4, okay? So do you agree that 2 times is 1 time around? Remember we talked about how that's sometimes that messes kids up, okay? And then 3/4, is that more than a half?
Yeah.
Is it as much as another 1?
No.
So where is he? He's in the second quadrant. In the second quadrant, is cosecant positive or negative? Positive. Okay, so I know he's positive. I know his reference angle is what? Pi over 4. Okay, pi over 4. So here's what I'm gonna do. Y'all look, I don't do cosecants, secants, and cotangents. I do their reciprocal function and I flip it. Okay? So who's his reciprocal function? Sine. So who is sine? X or Y? Y. What's the Y value at pi over 4? Square root of
2 over square root of 2.
what is it?
2 over the square root of 2.
Square root of 2.
Square root of 2 over 2. You just got the square root. Square root of 2 over 2. Okay, now here's what, remember how I kept telling you to know that this is also equal to what?
1 over square root of 2.
1 over square root of 2. So this is where it would kick you in the pants, okay? Because when you flip this, what do you really get?
Square root of 2.
The square root of 2. And if you wrote it like this, if you flip this guy right here and you wrote it as 2 over the square root of 2, I would not give you credit for it because it is a fraction and it's not reduced. Here's what happens. If you rationalize this fraction, you multiply by the radical of the square root of 2. On the top you get 2 square root of 2, and on the bottom what's the square root of 2 times the square root of 2?
1.
What happens to these 2's?
Yeah, 12.
So there's my answer. Okay? So here's what I'm saying. Every time I do something like this, I write it like this. So hoping that it sticks in my brain. Okay? So that if I ever do need to flip something, I'm going to go, oh, wait a minute. That's one of those crazy ones. That's really 1 over the square root of 2. Okay? Colton.
Okay, how'd you get I know what, like, the y value, but why is the y value sign?
Because cosine is x. We
But-
want some y.
Isn't it y over r?
Yes, it is. But I'm using the unit circle.
So as long as you know the reference angle, you can figure out. Okay.
Mm-hmm.
Wait, no, reference.
Y'all listen to me. This is why I don't have to know the whole entire unit circle. As long as I know that all students take calculus and I know where everybody's positive and negative, then honestly, the only part of the unit circle I'm going to use is the first quadrant. But you have to think about this every time. Where am I and what's my sign? That's really important. Okay? Even on this one right here. Why? Because he was not one of our values on our unit circle. We didn't go past 2 pi. And this is more than 2 pi. Okay? So you need to know where you are so you'll know what the sign of that function is in that quadrant. And then you can always just go back to his reference angle. The value of it is the reference angle, and then you pop a sign on it, and then you're good to go.
And he's positive because sine is his.
Because sine and cosecant are reciprocal
Yeah.
functions.
Okay.
So remember, it's whatever the letter is, and his reciprocal function, they're the only positive ones. Everybody else will be negative. Okay, anybody got a question? Sean?
What would be the reference angle of 180 and 360? Would it be 0?
Yes.
Okay.
Because they're not in the quadrant.
They're not, because they're quadrant angles. And listen to me, quadrant angles, I do totally different. You're gonna do some quadrant angles today. I'm not going to, but you are. So here's the way I do a quadrant angle. Anytime it gives me a quadrant angle, here's what you would see. Because I'm not as good as you guys are, okay? I'm trying to train y'all to be unit circle people. I am not a unit circle person, okay?
What?
So, I mean, I can be, because I can slap that thing on my paper as fast as you can, but, okay? So, but on my paper, you would see this, and then you would see the 2 triangles, a 45, 45, 90, and a 30, 60, 90. That's what you would see on all my, if you went and looked at all my keys, that's what you would see, okay? Because I'm a triangle person, all right? If you ask me about a quadrant angle, this is what I'm gonna put on my paper.
I just now realized what the AST, I just now realized that's all sine, tangent, cosine.
That's exactly right. All are positive, sine and cosecant, tangent and cotangent, cosine and secant. Sometimes you just have to say it 90 times, right, Lizzie?
I thought S was like
Sometimes
sum,
you just
like
have
sum
to
of
say it
When in
90
doubt,
times.
go to triangle.
No, I thought like S was like sum, okay, one of them is.
Some of them
Some
are,
of them are, and
yeah.
then tangent,
Guess
two
what?
of
You're
them are,
close to the desk.
and then two of them are,
Two
and
of
then I didn't know what C
them.
was.
It's cooking. And C is cosine, all right? So, good job. All right, anybody got a question? Yeah, there's a couple there. All right, so here's the next one I want you to do, okay? Now, we've done one kind of like this, but they added something new to it, so I want to talk about it. So this is example 6, all right? And it says, first of all, theta is in quadrant 2, okay? And then they tell you that the sine of theta is 1/3, and they want you to find the cosine of theta using identities. I like it when they tell me how they want me to find it, because y'all, that's like a big old fat clue, right? They're going, hey lady, you probably need to use an identity to do this one.
But what if you
Okay?
don't, like.
It's like a hint.
What if you don't remember, like, how to do that, a specific way, can you do it
Wait,
another way?
you don't remember identities? Because I'm pretty sure they were on your memory test. Okay? Now listen to me.
Well, that's the one I'm asking.
Okay, so, well, then we need to fix that. All right, so here's what I'm gonna say. We've done this problem before. We've done this problem before, okay? But they added this onto it, okay? When we did this problem, the only place that we ever dealt with any angles was in the first quadrant. So you knew everybody was positive. So if they tell me it's in the second quadrant, what do I know about cosine?
Negative.
Yeah, automatically I'm like going, wait, why are they telling me this? Oh, because in the second quadrant, cosine is negative, okay? So now I want you to think of an identity, and it can only use sine and cosine.
Sine squared plus.
Oh.
Yes,
Am I wrong?
because what are a lot of kids thinking? Tangent is sine over cosine. Y'all, that's 3 functions. Tangent, sine, and cosine. And when I only know one of them, you can't solve an equation that has 2 variables in it. Okay? So yes, you can only use sine and cosine. So sine squared
Theta.
plus cosine squared theta equals 1. What is sine theta?
1/3.
1/3. So I'll plug that dude in. Squared plus cosine squared theta equals 1. What's 1/3 squared?
31.
What?
1/9.
1/9. Square the top and square the bottom. Come on, guys.
Over.
1/9 plus cosine squared theta equals 1. So now I'm going to solve for cosine. So I'm going to subtract 1/9 from both sides. Okay, now please tell me that you know that 1 minus 1/9
8 ninths.
is 8/9.
Yes.
Okay, now what am I going to do?
Square root of both.
Square root both of them. Okay, now listen to me. I'm trying to bring back some memories, okay? So when you take a square root in an equation, you have to be thinking about what? Plus or minus, okay? Plus or minus. So now we know that it's what? A negative. That's where that minus comes into play. So this is my cosine theta equals, what's the square root of 9? 3. On the top I have the square root of 8. Is that good?
No.
That's not a simplified
2 squared root
radical.
2.
Okay, so the perfect square that divides into 8 is 4. So what's the square root of 4?
2 square root.
Since I took its square root, it goes outside the radical and the other 2 stays underneath. So this would be the answer that would go over here. Negative,
Here's one.
negative 2 square root of 2 over 3. Negative 2 square root of 2 over 3. Anybody got a question? Now, let me ask you a question. No, never mind, I'm not gonna do this.
Okay.
Didn't go well with this problem, sorry. All right, so everybody okay?
Yes.
Okay, so we're on 3 problems, then we'll pass out a worksheet. So, example 7, it's actually just an ABC problem. all right? And here's what the direction says.
I love this one.
Use a calculator to evaluate, okay? So y'all listen to me. If it doesn't tell you to use a calculator, then what?
Can't use a calculator.
Don't use a y'all listen to me. On the test, if the test does not say use a calculator, don't use a calculator. I'm not looking for you to round an irrational number, a decimal off. That's what's happening. Sometimes they'll say, find the exact, what are they telling you?
Don't round.
So don't.
Use your calculator.
That's exactly right, okay? They don't want you to round, they want it to be exact, so it's gonna have to be with a radical and stuff like that. Does everybody understand? Okay, so if it doesn't say to use a calculator, don't use a calculator. So I'm gonna put 3 problems up here, and I want you to work these problems while I pass out your papers.
Is that 9?
Yes,
Oh,
I'm passing from the back so I don't walk in front of the camera.
What do you want us to
Oh, sorry, I forgot something. I think so I wrote it, it's right there, but that's not y'all's paper. Okay, is that better?
yeah.
That's probably the series, right? That's some lab rating.
Tyler.
Thank you. The negative 17 degrees, right?
So we're not going around on here?
Yeah, you are rounded, it
Second
says use
and
the
then sign.
calculator to evaluate. What?
Second.
that 5 or
then-
9 or
I
something?
What?
5 or 9?
No, second,
Add your calculator.
dude.
So it's 89.86. Yes.
They stapled mine and it wasn't supposed to be stapled, so I just cut it off. Because when you jerk them apart, you don't put it right. I can't clear it. Okay, so, are y'all ready? Okay, I'm gonna help you with the first one just in case you don't remember.
Yeah, I don't remember.
Okay? Now listen to me. Here's what I'm gonna say. Have I already taught you this?
Yeah.
Probably, yeah.
And you should know it.
I do, but I don't remember it.
Then you don't know it.
I know it.
No.
I
If
Cause
you
I
knew
know
it,
to
you
do it
would
when you
get it.
remind me.
Well, how many
Okay.
decimals do you want?
So, 4. 4 is proper for trig. Alright, so is there a cotangent button on my calculator? No. So what button do I have to use? Is reciprocal. And if I use the reciprocal function, then I have to use the reciprocal button. Okay? So this is what my calculator's gonna do. And then I'm gonna punch the 410 in. Now, I have to know whether that x to the minus 1, which is my reciprocal button on my calculator, okay, goes on the inside of the parentheses or the outside.
Outside.
Very good. Inside is where angles are. Outside is where sides are. Remember we talked about a triangle? Where are the angles of a triangle? On the inside. So if you're looking for an angle, guys, I'm not looking for an angle. My golly, I gave you one. Okay? So you're looking for a side, so it goes on the outside. Okay? So that's what you would punch. What would you make sure you were in?
Degrees.
Degrees. Okay, so I'm going to go to there. I'm going to make sure I'm in degrees. And then I'm going to press tangent. I'm using the reciprocal function, so I'll have to use that reciprocal button. 410, close the parentheses. When you're looking for a side, the reciprocal button goes on the outside. If I were looking for an angle, it would say second and tangent, and then my x to the minus 1 would go on the inside. We don't have any of those. Yes?
How many digits do you want?
4 digits. It's proper to round trig off to 4 digits. So 0.8391. Do you agree? Okay. So hurry up and do the other ones, and I'm going to tell you about the worksheet. What do I have to do on this guy?
Change it
Change
to
it to
rate.
Change it to radians. And then I just put it in there. Sine of -7. People, if you miss problems like this, shame on you. Okay? That looks like a big stinking present from me. Merry Christmas.
Thank you.
-0.65 what? 70. Very good. Okay? Here's another one where I have to use the reciprocal button. What's our function? What's the reciprocal function of secant? Cosine. So I'm going to say cosine, and he's going to open it up. Okay? And then I'm going to punch in pi divided by 9. Close it and use my reciprocal button. So cosine of pi divided by 9. Close it. I'm looking for a side. The reciprocal button goes on the outside when you're looking for a side. Okay? It goes inside when you're looking for an angle. Angles of a triangle are inside. Sides of a triangle are on the outside. So there's my answer. All right. Anybody got a question?
Oh, you put on the outside if you're looking for something on the outside? Oopsie daisies.
Okay. So everybody okay?
No.
No.
Not.
No? You're not? Why not? Okay, so I want to go over this worksheet for a second, and then I want you to get to work on it. Okay?
It's just a review, right?
Do what?
It's a review.
Yes, it is. You should be able to do this front page of this worksheet in about 5 minutes. Okay? So let's look at it. The very first thing says fill in this chart. I want the function definition. Sine, cosine, tangent, cotangent. Here, I want you to use opposite, adjacent, and hypotenuse. And I'll let you use OPP, ADJ, or HYP. You may not use O, A, and H. That doesn't tell me that you know what you're talking about. Okay? OPP, just exactly the way I always write them. Unless I'm doing a cheat on the side of my paper, and then I say, oh heck, a hill of ants.
Okay, so just on the front, we're just saying like y over x.
Sine, opposite over hypotenuse.
Yes.
Okay? Then on this column, you're going to use it in terms of x, y, and r. Y over x. R, pardon me. Y over r, pardon me. Yeah. Okay? All right. So stop. Stop what you're doing and pay attention to me, and then you can go back and fill in all the stuff. Here, it says fill in this chart using exact values. What does that mean?
Use the values that you're given.
Yeah, no calculator, people. No calculator. Simplest radical form. Notice it didn't say it had to be rationalized. If you want a radical in the bottom, leave a radical in the bottom. I don't care. Okay? So you're going to find the sine of 0, pi over 6, pi over 4, pi over 3, and pi over 2. This is the chart, isn't it?
Yeah.
You see what I'm saying? This is the chart, people. Okay? You can count from 0 to 4, take the square root, divide by 2. All right? Then it wants the cosine. This is the chart, but it's backwards because cosine goes this way. All right? So down here, fill in this chart with the word. I don't want the words. I want a plus sign or a minus sign. Okay? That's all I want. Plus sign or minus sign. It's going to be easier for me to read. The sign in quadrant 1, what is he? In quadrant 2, what is he? In quadrant 3, what is he? In quadrant 4, what is he?
Oh wait.
Positive or negative?
Oh, we're
That's
not
what you're
putting
telling me.
what it actually is, which is great.
Well, you don't know what it is. I mean, it's lots of different things in quadrant 1, but it's always positive.
Oh.
Okay?
Thank you for the answer.
Do it.
Let's go.
All right, look on the back. Oh, you're really going to like the back because here's the question. Knowing sets of Pythagorean triples is important. List 5 sets here. I listed them for you, okay? I don't know what I was doing. I ran off one that I had written the answers on like an idiot. Sorry about that.
Wait, so we don't have to do
Okay?
that?
So you don't have to do that. But you don't get the points for it either.
No.
Okay? All right. Now yours doesn't look like this down here, but it's fixing to because you're going to fix it in a minute. All right. So here's the next question. If negative 512 is a point on the terminal side of an angle, can you find r?
Yes.
How?
Subtract it again.
No, x squared plus y squared equals r squared.
Perfect, so you would find R. And if you know X, Y, and R, can you find sine, cosine, and tangent?
Yes.
Okay, so, Skip, yours is blank right there, but you're fixing to write it. Okay, so here it is right here. Find the sine, cosine, and tangent for, sorry. Find the sine, cosine, and tangent for these angles. I want it up here, and then down here at the bottom, I want you to find the sine, cosine, and tangent of all the quadrant angles. Okay, and you can, if you don't get anything written today, you can do it tomorrow. We're gonna make it due on Monday.
Wait, are we gonna have class on? Oh, yeah, that we don't.
Yeah, tomorrow I'm gonna give you a little review, probably be out of the book. It's only going to be on 4.4, I'm not making it on anything else. That's for everything, but
Do you want me to stop?
reviews, I'm just